In this video, we're finally learning what the connection is between these weird antiderivative integral things and area under the curve. So, well, basically the same thing. So pretty much, if I want this example again, 4x cubed from x is 1 to x is 2. This was the one we did with the rectangles a couple of videos back. Basically, we're wanting to find this area under the curve. You can use a bunch of rectangles to approximate it, and I encourage you to review that, just so you don't forget. But there's a really easy, quick way to get this. So the area between 1 and 2, it's the integral of 4x cubed. Now you might be wondering, hey, that gives you a function. That's not a number. Areas are numbers. Well, we need to do something called a definite integral. When I say definite integral, I mean you whack some numbers on the end there, and then we go through a little bit of an extra process at the end. So the first thing we need to do is calculate the actual integral of 4x cubed. So that's going to be 4x to the power of 4 over 4. Now we put it in square brackets. We don't actually bother writing the plus c when we do areas like this. We just put it in square brackets, and we keep the 1 and the 2 sort of on the end of the square brackets there. Now we can simplify this down a little bit. So this just becomes x to the 4 from 1 to 2. And then what we do is we plug in the top number. So that's 2 to the 4. Take away, and then we plug in the bottom number. So you get 1 to the 4. So that's 16 take 1, which is 15. Square units. That's the area. And I think it's worth just taking a step back here. Derivatives are all about slopes. We're doing an antiderivative, so we're doing like the opposite of a slope. And for some reason, that gives you the area under a graph. Math is just beautiful. Like I just can't believe that it works. Like, what does slope have to do with area? Anyway, you can graph this on your calculator, 4x cubed, there it is. And there's actually a tool to do integrals. So you can go into Gsolve, you can head across, integral. Generally mixed is the best option, so you go mixed. You type your bound, so you type 1, hit enter, and you type 2 and hit enter. It'll shade in the area, and it'll tell you it's 15. Good stuff. All right, find the area contained by this one, 4 take 2x from 0 to 2. Let's shade that area in. It's this lovely triangle shape. We probably don't need integral calculus to calculate this area, but let's give it a go. Area is the integral of the function from 0 to 2. Let's work that out. So the integral of that, 4, goes up to 4x, and then this is 2x squared over 2. We need to put square brackets around it, and we're going to go from 0 to 2. Okay, we can simplify that down a little bit. 4x take x squared is the function from 0 to 2. Now, we need to plug in the top number. So that's 4 lots of 2 take 2 squared. So that's plugging in the top number. And then the bottom number, 4 lots of 0 take 0 squared. If we work that out, that is 8 take 4 in that first bracket, take nothing. So that's 4. Now, it probably felt a little bit silly to do that because it's a triangle, right? The height is 4 and the base is 2. So the area should be half base times height, which is 4. So thank goodness our calculus agrees with our geometry. That's always a good sign. Find the area from 3 to 4. So it's a very similar process. Basically, you're just going from 3 up to 4. You're shading in that area there. And we'd like to find that area. So let's go through it. The integral of 4 take 2x from 3 to 4. Now, so that's 4x take x squared was the antiderivative. I just jumped forward a step there because we've already seen it once. So that's 3 to 4. Now we need to plug in 4 lots of 4 take 4 squared. That's the first bit. Now we need to plug in 3. 4 lots of 3 take 3 squared. So 4 lots of 4 take 4 squared is actually 0, conveniently. And then 4 lots of 3, so that's 12. And then 3 squared is 9. So this becomes 0, take 3. So the area is -3 square units. Okay, when I said the integrals and areas were basically the same thing, they're not always the same thing. So we got -3. The short answer is the area here is actually 3 of that weird shape thing there. But because it's underneath the axis, we pick up a minus sign. So when you're doing a definite integral like this, this is not necessarily an area. And if you calculate a definite integral and the question doesn't say anything about area, you actually shouldn't say square units on the end, because definite integrals don't necessarily mean areas exactly. So this is the integral is -3, but the area is 3. And watch out for that. Now let's graph this and take a look. So if we go 4 take 2x, I think that's our function. And if we type the x properly, we'll have a draw of that. We'll match our window to what the question says. I think that was like -6 to 6 on the y-axis. Let's have a look. There we go. We'll review our answer from the very first bit. So I claim the area for that first bit was 4. So if I go gsolve, scroll across, integral, mixed is the good one, 0 up to 2. Yes, the integral is 4 and the area is 4. If I go shift gsolve across, integral, hit mixed, and I type 3 up to 4, it says the integral is -3, which we got, and the area is 3. So integrals and areas, different things. Okay, next, find the area contained from 0 up to 4. Okay, so let's try this. The integral, so 0 up to 4, this is the same function as before. So that's going to be 4 take 2x. So that is 4x take x squared. So that's going to be 4 lots of 4 take 4 squared. That's the first bit. And then it's 4 lots of 0 take 0 squared. That's the second bit. So that's 0 take 0. So the area is 0 square units. And that checks out, right? Because when I integrate from 0 to 4, I've got that wonderful big triangle there. And I've got that other wonderful big triangle there that I'm adding on. And clearly the total area is 0. I mean, it's not. But so what's going on here is we already saw the area of that first bit was 4. So the area is 4 there. Turns out the area here is 4. But since this area is considered a negative and this area is considered a positive, they sort of cancel out. So you get 0 when you try and do the integral. So no, don't do this. If you actually want the area, what you should do is you should integrate from 0 to 2 of the function. And you should do that separately. You should integrate from 2 to 4. Now, this thing's going to come out as positive, so that's all good. This thing's going to come out as negative. So that means you've got to make it a negative. And then both of those will cancel out to be a positive. And then you will actually get 8, which is the true area that we're looking for. Now, conveniently, a calculator can handle this for you. So let's just exit out. I'm just going to go for take 2x again, just to get rid of all of our other shading that's on there. Gsolve, scroll across, integral. This is why I've been saying do mixed, 0 and 4. You'll see that the integral is 0, but the area is 8. So that's the difference there. Okay, that's all the ones I'm going to be doing by hand in this video, but just be aware that, like, if you wanted to do this one by hand, you go 1 take x squared, you get the antiderivative, and so on and so forth. So let's just do this with the calculator, because quite often you'll be finding the areas with the calculator. The graph that we're interested in is 1 take x squared, so we'll draw that. There's a picture. We can swap our window, so we go -2 to 2. And the y appears to go -2 to 2 in this picture as well. So we'll just draw that. Shift G solve, go across to integral. Now, mixed, it will highlight the x-intercepts for you. So you can usually just hit enter there, scroll across and hit enter there. 1.3 recurring. Wonderful. This one is just the upside down version of it, but we'll do it properly. So you got x squared, take 1, draw, there we go, shift G solve across, integral, mixed, enter on the first one, scroll across, enter on the second one. The integral is -1.3, but the area is 1.3. And the integral was -1.3, just so we know. Here the integral matched the area. And the reason the integral is negative is because this is underneath the axis, whereas this area that we're looking at was above the x-axis. By the way, if you want to do this by hand, you do have to find the x-intercepts. They're -1 and 1, which is easy to spot here, but sometimes they can get a bit messier. Find the total enclosed area for x cubed, take 4x. So the integral I can already see will be 0 because the upper bit there and the lower bit there will cancel off. I shouldn't assume that it's 0, but I wrote these questions so I know that it was 0 and they sort of look about the same. But x to the power of 3, take 4x. Better make sure that x is the proper x. Shift G solve across, integral, mixed, enter, scroll across twice to the next intercept, hit enter. The integral is 0, but the area is 8. Similar to that triangle example that we saw before, this was 4 and this was -4. So if you add up the actual areas, you get 8. Okay, one more example here. Consider that function. We don't actually have the equation for it, but we know a few definite integrals. So the integral from -2 up to 1 is 5, and the integral from -2 up to 4 is -3. Now, it has x-intercepts at -2, 4, and 1. Find the area of A. So the area of A is just the integral from -2 to 1 of the function. And the question has given us that information. They've said it's 5. Area of B is minus the integral from 1 to 4 of the function. And the reason I've thrown in that extra minus sign is because B is underneath. So this is minus, and they've already told us what well, they haven't told us what that integral is, have they? They've told us 2 pieces. So they've told us that this area here is 5. And then they've told us that the integral from -2 up to 4 is 3. So this would be the area A, take the area of B, because B was underneath, equals -3. So we know what A was. It was 5. So therefore minus B is -8. Therefore B was 8. So I'm hoping that makes sense. If this is 5 and 8, and the 8 gets interpreted as a negative, then that would give you -3 when you integrate across the whole thing. So I think we've actually done it. B was 8. Find the total area enclosed by the function and the x-axis. So this is just going to be 5 plus 8 is 13. So you interpret all the areas as positive and find the integral from 1 to 4. This is just going to be minus b. So it's -8. So it's the same as the area there, you just interpret it as a negative. And because they're just asking for an integral, no square units on this answer. When it asks for area, you put square units. When it asks for an integral, you don't. And integrals can be negative.